So in this tutorial, we're going to look at the difference of two squares. Now this is one of those little nuggets that is really worth remembering because it can save you a huge amount of time. Now what is the difference of two squares? It's anything in this form here. P squared minus Q squared, or indeed anything squared minus anything else squared. So a couple of examples, we've got y squared minus 1. And yes, that is something squared minus something squared because it's y squared minus 1 squared. Okay, and then what about this one? 9a squared minus 4b squared. Well, 9 is the square of 3 and a squared is the square of a. So this is 3a in brackets squared, and then similarly minus 2b in brackets squared. Now why is this so useful? Well, it's really easy to factorise. P squared minus Q squared can always be factorised in the same way. P minus Q times P plus Q. And if you want a little bit of practice at multiplying out brackets and want to understand why this works, just multiply out those brackets on the right hand side and you'll see what happens. Use FOIL. There's a whole nother tutorial on that. Why is this worth remembering? Well, it's very useful when factorising, and it also saves time when multiplying out. So very briefly, let's have a look at some. So in this first one, we've got 9x squared minus 25, and we should be able to see that that first bit is the square of 3x, so it's 3x all squared, minus, well, 25 is 5 squared, is it not? And using our rule, that p squared minus q squared is p minus q times p plus q. In this case, if p is 3x, we get 3x minus 5 times 3x plus 5. And so we factorised a quadratic with no x term very easily. What about this next one? We need to do a little bit of harder work. What is a to the 4 as a square? Well, it's a squared squared, a little bit of laws of indices there, minus, this one's a bit easier, having done question 1, we should know that that is 2b all squared. And now we've got our p and our q, p is a squared, q is 2b, and we get a squared minus 2b times a squared plus 2b. Ooh, not plus b, but plus 2b, there we go. Now what about this one? This one, again, we're going to need the laws of indices here to express these two things as squares, but we can do that. The first one is 3 to the power of n squared, and the second one is 2 to the power of n squared. And so our p, as in p squared minus q squared, our p is 3 to the n, and our q is 2 to the n. So we get p minus q, so that's 3 to the n minus 2 to the n, times, in another bracket, 3 to the n plus 2 to the n. Okay, now why would you ever need to do any of those? Well, it might crop up in a question, or you might just be asked to do it. So that's factorising. Let's have a quick look at multiplying out as well. This is almost easier. We can just say, look, here are my p and my q, x and 2, there they are in both brackets, x minus 2 times x plus 2. And so I can almost just write down the answer. This is x squared minus 2 squared, p squared minus q squared. And so that is x squared minus 4, if I want to simplify that. The next one's got some horrible square roots in it, but again, we can just deal with them. P is 3x, q is root y. There they are again in the second bracket. So p minus q times p plus q is equal to p squared, so 3x all squared, minus, well, I will do it the slow way, I'll say that's root y squared. 3x all squared is 9 times x squared, minus, well, what is the square of the square root of y? It is, of course, just y. Okay, so I get 9x squared minus y. Now this last one is quite a common sort of question. Simplify something with surds in it. And you may well have to do this as part of another surd question, or you might just be asked to do it. But again, we can identify our p and q. There's p minus q, so root 5 minus root 3, and p plus q, root 5 plus root 3. And we can, if we do this then, we get p squared, so root 5 squared, minus q squared. Well, q is root 3, and that's squared. And this is, well, root 5 squared is just 5, and root 3 squared is just 3. And this turns out that very complicated expression there is just 2. And that's very useful in something called rationalizing the denominator of an expression with surds in it. There's another tutorial on that. Anyway, the difference of two squares, remember it, it's incredibly useful.